Buckle up for AEC Trailblazers, the Founders Files, where we crack open the stories of the brightest minds in the AEC startup scene. Forget institutional pitches. We're diving deep into the real personal journeys of these industry disruptors. Get ready for some casual chats firsthand.
Hello, and welcome everybody to the AC Trailblazers podcast, where we interview the most amazing founders of the AC. Today with us, we have Federico Fernandez. He has a background in computer science and has an amazing career going from being a serial entrepreneur, co-founded Synthesity. Then he was the director of software engineering at Autodesk. He co-founded UrbanSim, and currently he's the CEO of UrbanLee. It's a great pleasure to have you here, Federico.
Thank you. Thanks a lot for the invitation.
Did I miss? Did I miss something from the bio?
No, that's very accurate. Yes, I started in computer science many years ago. In fact, doing theoretical research, like static analysis, very specific topics on research and computer science. Yes, and at some point I got in love with cities and with these social models, simulation models, and yes, I basically started by doing research at UC Berkeley with Paul Waddell, that is a very known professor, and then became a friend and a partner in these land use simulation models that we will talk about probably more. And yes, then that brought us to start creating startups, but it was just by like a need because we were doing things from the university, but we found limitations on being in the academia, so we like switched to founding startups, and yeah, here I am.
It's so interesting because typically, I think in the AC, most professionals, right, architects, engineers, they go from, hey, I don't like to be a traditional architect and I'm going to go into technology. But it's not as common as people coming from the computer science background into, uh, the AC or urban planning like you did. How that lab started? Like when you were at Berkeley, like you mentioned, it was like something you did on purpose, or how was the process of getting in love with cities?
Yeah, no, I have to say that at some point I found a way to connect my research that was in particular I was applying my research on traffic lights systems in Argentina, where I am originally from. I was working on these state machines, but in finding ways like to prove theorems on those state machines. So like trying to guarantee that there was no green state in an intersection of traffic lights. That it's super easy to do if you only have one intersection, but we were like optimizing the timings of the traffic signals in different points of the city. So I started doing a PhD applying that to this particular problem. So that brought me to the cities in some way. And at the same time, before that, I was working in the industry in a company that we were simulating the electrical grid. So basically doing, allowing the operator of the utilities to do different kind of changes to the network, and like anticipating or simulating how those changes will affect the different components of the network. So somewhat connecting both of them, and with my passion. I love to play SimCity when I was a child, and also many other similar games like Transport Tycoon and all those games where you have to administer like different systems and all that. So connecting all that, and also my passion for like the Conway scheme of life. So perhaps this is a bit to computer science, but those are kind of games where you have this cellular automata, and you put some rules and you see how interact with the particular environment. So connecting all of that, I said I have to find someone doing social simulations, or finding ways to research on what I call this emergent behavior. So finding ways to anticipate how people or agents, or in many ways, will react to changes in conditions of the context. In particular, yeah, I got in touch with Paul Waddell, that was making, doing research from the 90s in this topic, that is land use simulations. So basically understanding how land use will change in a city. It's a discipline that has probably 50 or 60 years of research, but the big change that happened by the end of the 90s was in the geospatial component to this, because before GIS was not possible because of performance and all that. So basically we connected these Asian-based models with geospatial. Paul was doing that first at the University of Washington. Then he moved to California, to UC Berkeley, just before we met. That was in 2008, I think. And yeah, somewhat we connected, his knowledge on the social simulations and sciences, and my experience in computer science. We started working together, and there was a lot of interest from in our important project from the academia was something that is called Plan Bay Area. That is, a plan that is done in the Bay Area around San Francisco, so Silicon Valley, all that the government was trying to plan for the next 20 or 30 years. They wanted to simulate different scenarios, and we had the simulation engine that was UrbanSim, that is an open source land use simulation model that was authored by Paul Waddell in the 90s and the early 2000s. So we had that, but what we don't have, or we didn't have at that point, was a way to visualize and communicate the results of the simulation, because simulations were super numerical, like text-based, so in a terminal with a lot of numbers, but very difficult to interpret for people that were not in the field. So we started the collaboration with the Purdue University, Carlos Vanegas, and many others, to create this 3D interface to show different scenarios. So we started to think on this, I always say, like a 5-dimensional way of visualizing things, that is taking the 3D plus scenarios plus time. So you add like 2 more dimensions to visualization. So you can see the city, how it looks now, how it will look in 10 years, how it will look in 10 years in some policy scenario. So for example, just to give more clarity, in that project, we had the scenarios like, trying to prioritize the density, prioritize public transportation, prioritize the, nature and some like ecological targets. So we simulate all of them, and find ways to go to community meetings with the result of the simulation, and allow people to see those different futures, and basically like structure the conversation. Something that I learned working in this urban planning field, coming from computer science, is that of course it's social, so you have the different people, different societies, and many times it's very difficult to structure productive conversations. So we realized that these models perhaps are not a kind of super accurate forecast. We of course try to forecast, but it's not like they are like a source of truth or a source to see the future. But they are very good on communicating like extremes or different scenarios and how policy can affect the future, and that usually helps open those conversations.
I think that was going to be my next question. Like, there's so much I can ask, from like, how the hell did you lead an algorithm to deal with all the traffic lights, which it's really hard. Like you mentioned, like if it's just a static three, I don't know, three lights or 4 lights, it's easy. But if it's a dynamic scenario that varies over time, and you have to synchronize the whole city. It's a hell of a algorithm. But I'm just gonna leave that outside the podcast. That's too much. Uh, but I think what you were speaking about simulation is just, it's great to hear that. And it's like you said, there's no way to predict the future. It's not never going to be a 100%, but if you at least you can give probabilities and a way to communicate potential of ideas, I think that's already a lot. But I also think it's really hard. Like, I mean, there are so many variables. How you we as architects like deal with variables on a building, and it's already hard. How you do it when it's a city?
Yeah, it's difficult, and in particular, land use, I think, is more difficult compared to other things that you can simulate on a city. For example, if you think on traffic simulations, you have the lanes, you have the streets, you have different flows. You can experiment with, different, trips that will happen in the city. But somewhat is a closed system because you have the streets, you have these flows, you have the trips. It's more or less closed, but you can change the number of planes, you can, add infrastructure, add transportation, all that. You have different scenarios. But when you go to land use, it's like another level of complexity or chaos, I think, in the system. Because yes, we are now in a kind of transition, I think, from the let's say 2010s, that we were still thinking on this model as kind of oraculous that will, okay, you have to do a 30-year regional plan, so you run the model and you get some results, and then you basically plan according to that forecast from the simulation. I have been trying to push a lot in, let's say, in the last 5-6 years when I started my last company, Urbanly, to start thinking on this model as kind of sandbox, like places where you can basically experiment with policy. So it's not like, of course, you are trying to forecast what is the input of like the impact in the real world of a particular policy, but in a way, you can change policy and see effects in some particular area. And then, because I truly believe that the urban planning process is a human process. So it's good that who is in the driver's seat is a human. And then you can use these tools to, hide that process. But in the end, it's good if you can basically represent those complexities and not just do a couple of regressions and have some interval of confidence and publish your results. Because I always say that it's so chaotic. Cities are so chaotic that even if you calibrate your models, something that we did a lot in the past. So basically, we did what we call back calibration. So we created the model, then we went 10 years into the past, we simulated 10 years to the future from that and compare the results. But there is a very, I think, risky hypothesis in that methodology, that is that the city in the last 10 years will be similar to the next 10 years. And as you know, that's probably not true for any city in the world for any decade that you want to take. So basically, I think you need to start from the the other hypothesis that the city will change. So how we can embrace change, and to be more clear on the methodology, or how can we model cities. And basically, we use these agent-based models. That means that we create synthetic populations. That means in turn that we will take the census data that usually is aggregated, and we synthesize that up to the household level. So, of course, we don't have information up to the household level in the census, but we take the totals we have and some surveys on households that exist to understand more about the demographics. And what we get is, yes, household with certain demographics for each of the houses of a particular area. And then having that, what we do is to try to model what we call the offer side and the demand side. So the offer side is basically real estate developers. So we have agents that represent the real estate developers. They compute performance all around the city according to the policy the policy scenario that is the context of the simulation. So basically, real estate developers will evaluate many parcels that are available for greenfield development or for infill development. They will use the economic simulation that we have to understand the costs and the cost of money, and also predicting vacancy rates in the area and all that. So at some point they will decide to build in a particular place of the city. That when that new building is finalized, we introduce that building to our market simulation, and then the offer side comes. So you have immigration, you have new households forming as the simulation progresses, because this is not just done for the base year of the simulations. It goes for, let's say, 20 years. So as this initial population evolves, for example, there is a new household and we try to rent or buy a new dwelling units, then you will go to this market where the real estate developer introduce a new dwelling unit there, and of course the market will clear, will have different times, and that's the way we can start understanding how prices will evolve, how employment will evolve, how the city will grow basically. So of course it is one way to simulate, but in my experience, in these super chaotic environments, or when you are trying to simulate systems that are super chaotic, so I'm saying chaotic in more like a computer science definition, that is, you have inputs and outputs of a system, and there are systems where if you change the inputs just a little bit, the output won't be very different. But there are chaotic systems where perhaps you change the inputs just a little bit, and the output change a lot. So from my experience in computer science, using the heuristics and many methodologies for cities and for this particular kind of simulations, driven simulation by agent-based models is the best. Of course, we have other models that helps, like an accessibility model and pricing model and development tracker, that will use another techniques, but like the main thing is these agent-based models.
It's so interesting. And what you were talking about, the whole process and these chaotic models, there is something that I want to know, because like when we architects, like on a let's say household or on a single building, right, there's a phenomenon that we are kind of always late. Like, for example, when nowadays kitchens are larger, right? Kitchens, and the life of a family, it's on a kitchen, right? And you get the big aisle in the middle with a table, and friends come over, but that was not like that in the 80s. Kitchen was a really small thing with a microwave, and that was it, right? So we kind of try to adapt. We say we influence kind of like life of people a little bit, but the reality is just we just adjust to how people want to live, right? And we're always a little bit late. And I was thinking, like, well, in a house you can do whatever you want, right? Because it's just a house. As long as the client can pay for it and want the idea, that's it. But on a large scale like a city, it's not like you can say, hey, let's just destroy half of the city, or let's just build a huge park in the middle, or a highway here. You cannot. So how do you deal with that? Do you feel that when you do this kind of simulations, you need to take into account what's possible also, or how do you deal with that uncertainty that you're kind of always late, like we are as well?
No, that's a super interesting comment, and on being late, we had perhaps it's not the same example, but at some point we had to implement what we call a look ahead of the agents, because they were all the time like taking decisions on like the current simulation context. So let's say, for example, we know that in 2 years from now there will be a new subway metro stop that will happen, and in our previous models it was like the agent has to wait until that stop is like enabled and I mean running. The train was running, the metro was running, and then at that point it will take starting decisions, taking into account the new accessibility, for example, that will bring that to the area and all that. What then had to implement was basically a look ahead that you can you as a user of the simulation can configure how large and how much information the agent receives. But now, for example, it will see 2 years from now and anticipate that there will be better accessibility, that will change prices, and will like anticipate to that in any case it's a very specific example. Then about your question and what is possible, of course when we call we seed the simulation. So basically we create the initial context of the simulation. We try that context to be like a kind of digital twin, so like equivalence of what is possible in reality. So for example, something that we have to do and take some time is to understand all the zoning constraints that are valid for the start year of the simulation, and introduce all that to constraint capacity, because of course you can allow to these real estate agents to do anything, but they will have to also be in line with the constraints that are in the simulation context. Of course, in a particular scenario, if a planner that is the user of the simulation wants to experiment, let's say in 5 years I want to upzone many different 500 meters from transit stations. So, you can do that in a specific scenario. So what is possible then, it's about what the planner wants to experiment with. So in the simulation, in some sense, it's a simulation. It's like SimCity, you can like erase everything, do anything. But in terms of like creating this simulation context and the scenarios, the rules, are set by this planner. Then what is important to understand is that in agent-based model, it's not that like you are directing these agents in one direction or the other. So basically, you set the rules of the game and you set these what we call objective functions that they need to or we want them to optimize. In the case of real estate developer, probably will be basically revenue or profit. But you set these rules and then you see what happened, with the agents interacting in that environment. And there is also one more, application of scenarios that is related to what you were describing. That is many times we face uncertainty. For example, we had a pandemic like a few years ago. We don't know, hopefully, but we don't know if in 10 years we'll have another pandemic. And perhaps there is a city that wants to experiment with that. So we allow them to create scenarios. When I always say that many times when there is uncertainty, create a new scenario. So you have a scenario without pandemic and with pandemic. We don't know if a new pandemic will happen, but at least you are covered. And something that is more, technological is that I pushed a lot to make these models run very fast and the scenarios be very easy to create. Because in the past, and past, I say, 10 years ago, not very distant past, these models will take to run days or at least hours for one scenario and perhaps for 1 year. And now they're, much faster. We have to do a lot of research to push that. Basically, not because it's fine. If you have to run one simulation, you can wait, let's say 1 day, whatever. But
Yeah.
If you want to run many scenarios, that I think is good. I'm trying to, motivate the creation of many scenarios and experimenting with very different features. I think it's super important that they are very light to create, basically.
Oh, that's really interesting. And related to that, like, and I know speaking about something that we don't know if this is going to happen or not, but uh, uh, when people speak about quantum computing, right? Like I always think like to my mind it comes the human body and how you can simulate in cities. To my mind, that's I don't know why, but that always I'm sure there are many more uses like I don't know hacking passwords and doing so many things, but for me it's just that. But like how do you think it's going to change it? Like if that happens in 10 years, because maybe it's not going to happen next year, but maybe in 10 years it's a reality that those computers are more accessible, um, and more reliable. Do you think that's going to change how we simulate cities completely?
Yeah, I mean, because right now I mean, the algorithms that we use are mostly, let's say, data science, machine learning, heuristics, optimizations. But what I think will be a big jump or gap on this field will be when, because I am talking about agents, and agents it's a concept that comes from the 70s, that basically an algorithm that represents a real world entity with some decision capacity, and that optimize this particular function. But now we have AI agents that, of
Yeah.
course, have many more capabilities that what we were able to do with this machine learning, that basically is a very sophisticated decision tree. So we model this real estate agent, and it has the look ahead, it has a risk profile, has a targeting typologies that will meet, has a way to compute performance and compute profit, and that's a lot. And we get a lot of very unexpected behavior when we run this massive simulation. So that's good. But what about, instead of having those agents, let's think that generative AI it represents each of these agents. So it's like closer to a real person taking decisions.
Yeah.
And of course, that currently today is not possible because of the computing power. We are doing simulation for, let's say, with 2 million agents, and running 2 millions LLMs or 2 millions AIs right now. Probably it's a lot, because you need those AIs like to live in some way. So to not only to run to take one decision. It's like it's 20 years of simulation, and every day they are taking decisions. So it's really a lot. So yes, I hope at some point, if there is a kind of very important jump on the capacity, the computing capacity we have, it will be wonderful to basically incorporate more and more complexity on these agents, and how far we can get on representing reality and decisions of people and agents in the system.
The matrix, it would be like when you were a kid, right? And you had your, I don't know, you remember those small pets, Tamagotchi, I think it was the name. Remember that you have to take care of them, like kids are gonna, oh, I have my own city and citizens are really happy, and and they're gonna be like real, like agents, thinking agent. I don't know, it's just gonna be so interesting for us. It'd be something new, but future generations it's just gonna be completely different story. It's just incredible.
And at the same time, I think it's also, I mean, it's important to have that look ahead into the future, but also understand how current technology can help cities and make real impact, because that is something that was like a kind of topic in my career, because I was in the academy, and we were like doing very cool research, but then we realized that perhaps municipalities have different problems or simpler problems, and we were with the super sophisticated models, and perhaps problems in cities in reality are simple. So it's good to also have that connection with reality. So think on the quantum computing in 10 years, but at the same time, saying, okay, what are the problems of the cities today? What are the questions that they want to answer? And okay, from the technology that we have available, what is the technology we can use in now?
No, that's a great point. And sorry to compare to buildings, but again, like, speak to a client, you do your thing. Dealing with municipalities where it's a group of people with a lot of interests and politics and locations, right? And weather, like there are so many variables. Like, how is it for you? I'm curious because I've never done it. Like, to deal with, because I guess they are your clients, or how it's dealing with them and dealing with different municipalities across the world. How's the 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 process, I guess.
Yeah, no, I really enjoy like to travel and to learn, about cultures and how cities work in different parts of the world. In fighting, as part of Urbanly, I did a very long road show that started in London for a conference. Then I went to Africa, Saudi, like Doha, Singapore. I ended up in New Zealand. So it was, super long. And yeah, it was super interesting. Like we did prototypes in Doha, in Qatar. And for example, we had to change completely how we were locating, families, what we call the household location choice model. That is the model that we, basically put households in different points of the map, because, how people, made decisions on where to locate in Doha is super different from how that happens in Rio de Janeiro, in Brazil, or different places. So of course it is a challenge. That is the part that is super interesting to me, because I am a technologist, but also super interested on more on the human side of all this, and interacting with the the local planners, understanding the culture, trying finding ways to convert that into the agents. So converting human behavior in algorithms, that of course is something that is not 100% possible, but we try to get as close as possible. And yes, so, as I was telling you, I had my first two startups were very focused on the US, were founded in California, in Berkeley, with this research team from UC Berkeley. And we were basically working with MPOs, so metropolitan planning organizations in the US. And they have very strong rules on how they plan and they do their job. Planning in the US is also has some particularities. And we were using UrbanSim, the point so small. And at some point we got the project in South Africa. And we went there and tried to apply UrbanSim. And I remember talking with the city officials there, and I was talking about how we compute prices with the market simulation and on that. Someone that was sitting there told me, but here he told me, like, 40% are informal settlements, 30% are different kinds of social housing, and perhaps only a little bit is market rate housing. So how you will cope with that? And at some point I said, we need to start thinking things differently. and we kept working a lot in the US with UrbanSim. So basically, just to recap, I have Synthesity was our first startup. We're working on a lot of geospatial visualization, because we had the simulation engine, but I'm talking around 2012. So GIS was very weak, so it was super difficult to visualize a deep region, and with different scenarios, different times, it was impossible. So we started, basically, we created our own engine for geospatial visualization. The good and bad part of that was that that piece of software was super interesting for Autodesk, that at that point were like doing a kind of revamp or of some of the products. So they acquired our company. We went on to work for them. But the second company, the one that we had with Paul for, let's say, 8 years, we worked a lot in the US. And on year 6 or 7, I started to and to see these problems in Africa. Then we went to Bogota in Colombia, also saying similar issues. And when I started Urbanly 3 years ago, I said, no, I need to have modify the models to make it as easy as possible to adapt to different cultures, because it's something that is, super interesting, and it's super important for the models to have more impact in different parts of the world. So yeah, that's it's a very important topic.
No, yeah, and it's, I don't know, I think it's fascinating, like, the way cities are designed. Not that one is best than the other, right? Like I don't know, America is is the same everywhere. There's a big structure and a lot of highways, and like it's always the same thing everywhere, right? But then you go to other places where it's completely organic, like you said. I've been to South Africa as well, like Pretoria or Durban or Cape Town. Like, and there are big areas where it's completely, even in Argentina, it's completely organic. And And it's just so, for me, when I got into those neighborhoods, it's just so interesting because, like, sure, it might be complex if you want to drive through it, but if you want to walk, it's just incredible, right? Because they kind of do a mix between, like, trees and nature and the shapes, and it's not that I'm romanticizing, like, poverty or anything like that, but
Mhm.
from a urbanist concept, it's just amazing. I don't know, it's just fascinating how things change on different scales, economic situations, countries. I don't know, it's just
And that's
incredible.
along those lines. At some point, I always say in my beginning of my research on this topic, I did some experiments on like growing cities organically in some way. So planting a kind of seed of people, and then understanding how, if there are no rules, no zoning constraints, what will happen if we allow them to treat their own streets and all that, how that will go organically, and then start to add different constraints and see how that affects, and perhaps it's somewhat a bit theoretical. But then when we go to the informal settlements, for example, in Argentina or Brazil, uh, you see some elements of that. So there is something organic happening there for sure.
Yeah, it's just interesting because well, it's just like government, right? Like, you cannot say no government is good, too much government is bad. Like, it's the same. Like, you need structure, or everything in life, right? There are things that you need a lot of structure, but things that would be great to make it organic. And I think that cities is, like, you do it really strict and planned, or it's completely opposite. There is not an in between, I feel.
Yeah, it's super difficult, and also for the malls, because the initial malls that we did were for the US, where zoning is very strict, and with the land use types and all that, and of course that's the easiest for us, because you can constrain very easy in a very easy manner the mall. And then yes, we went to do some experiments in informal settlements and all that, and yes, I'm still finding that middle solution that you were describing. I know where it is.
Maybe when you get hired to design a new city, that is not really common, right? But it happens.
Yeah, we did some work on that with Peter Caltorp and Carlos Vanegas, when we were working mostly on procedural geometry, because we were connected with the people doing, like Pascal Mueller and others, doing in City Engine, this procedural software that then was bought by Esri, and we were experimenting a lot with procedural geometry and generating cities and all that, and we had actually a project in India where the goal was to maintain was greenfield development, so we had like complete freedom, so we created this application to move different neighbors around and see some analytics and on that back in 2012, 2011. And there the objective was the visibility of a particular landmark, because that was super important for that particular town in India. And I remember, doing all those calculations and moving things around and seeing how we can like value that in these analytics, and finding ways to yeah create that city from scratch in some way, but maintaining some, or trying to optimize some particular metrics.
Interesting. Interesting. I mean, you try and play God, and no way you can reveal the whole city, but the experiment, it's so interesting. And I don't know. It's just, for me, it would be a dream. Like, imagine you're hired to build a city from scratch, like, I don't know, Brasilia or any of these newer cities, or Chandigarh, or I don't know, the most famous cities that's been built in the last 100 years, right? And the reality is, like, I'm not a fan of any of those. Like, it's just, well, there were failed experiments, right? Like Brasilia, it's amazing, but it's a failed experiment. Like, the
Yeah.
idea was great if you think about it. The theory was great, and then, to be fair, they didn't have any AI models or anything to simulate when they built it in the 40s, 50s. I don't remember. um, but
Yeah.
it's just
When you do that in a void, it's like, for example, if you have to choose those metrics, probably you will use the metrics that are like trendy for that particular time. And in our time, there will be different. But what I think is interesting or very rich in cities is that, you know, like that melt of different tendencies in the different decades and how they interact and create like something new. It's like all that mix that makes the cities, I think, rich.
yeah, no, absolutely. It's like I don't know, Latin America. I feel it's a great example where we always
Mhm.
keep the layers of like a pre-Hispanic center with the church and everything, and then it grows to the 70s houses, and then now it's buildings, and you can see the layers pretty clearly. I
Yeah,
feel that because Latin America it's pretty new, right? Like you cannot say the same in Europe where it's hard sometimes to understand what's new, what's old. Same the US. Say US is all new and the same logic. So it's hard to get layers
yeah,
on the US. So
yeah.
no,
They are,
absolutely, just rich.
they are somewhat hidden. For example, in a presentation that I do about the land use simulation models, I have this example that is in the south of the US. I don't remember
Like
the
New
name.
Orleans or
Yeah,
what do you mean New Orleans?
because they have a kind of castle with walls in the French era. Even now, you can see like in Google Earth, like the walls of the Asian city. They are somewhat still there, but it's super difficult to. You have to like to cherry pick and be very know a lot about the story and that. Usually, yeah, that there's no story evident there.
Yeah. No, and I feel that I don't know, another concept what you were speaking about, just that like connecting the dots from you doing the algorithms of lights in the streets and um car lights. So in cities is cars, for example. Now if we get to a point where nobody's going to drive a car, right? Cars are going to drive by itself, right? What's going to happen? You're not going to need uh lights anywhere, right? On each, like you're not going to need it because computers will know when another car is coming, and they can, with the algorithms you can just do it, and they're going to be, I think they make the calculation, or you might be know better than me. There's a experiment when they did that if their cars are not driven by people, right, then not everybody's going to have a car, so the amount of cars is going to be reduced like a lot, and then streets are going to be completely empty. It's just of cars, right? It's just going to be 20% of cars. It's just going to be insane how that's going to change cities, for example, right?
And no parking because perhaps the car will come to get you and of course thinking about malls and connected with malls. Yeah, what is good about any automation that happens on cities is that it's much easier to simulate them, because if it is something that is following an algorithm, we can integrate that algorithm in the simulation. What is of course difficult to simulate are the economy of the nation, of that state, how that interact with prices and all like the human aspect of all this.
Yeah, and we're never be able to control it because we you can never understand the human behavior, right? It's changing. It's a
Yeah, of course, of course.
yeah.
For that reason, I always say that these systems are not miraculous. It's impossible to predict human behavior, but at the same time, I think they are very useful to understand different subsystems that are inside the city and understand cause and consequences and how different causes and different consequences interact, and have ways to experiment in a kind of sandbox with that. So that's the approach that I think is more useful for this kind of systems.
That's really cool. And I can speak about this for hours, but I know you're a busy guy, Federico, so I'm not going to keep you asking a lot of dumb questions. Um, but before we wrap this up, can I ask you a couple of ping pong questions? All
Sure.
right. What do you think is going to be the next trend in urban planning?
Well, I think what it will be interesting to see happening is to for I mean generative AI to have more knowledge on the basically on geospatial concepts, because of course there are now many GIS applications. You can write like kind of queries in natural language, and LLM will translate that into an API and whatever, and respond those questions. That it's good. It improves interaction, but still, I don't believe that any of the AI models will like be able to understand a map and like read a map and extract the knowledge that we as humans can see from a map. Like, okay, this neighborhood is this way and this way, and if we put something like this. So I think as soon as it would happen in 2 years, 5, 10, whatever would happen, and it would be very interesting to see how all the geospatial field will change when that happens.
Cool. And if you could collaborate with any person in history, which person would you choose?
Wow, can I say more than one?
Yeah, let's do two. Let's do two because it's
Two.
two.
Yeah, well, Sean Conway, that is this is very computer science. He's the author of this Conway's Game of Life. That is the first like cell-based automata from the 70s, and I cherish the evolution of that kind of models in the 70s, like being able to work with him, rethinking all those models. Yes, and the other one is my buddy. That is, I don't know how to describe him. He's at CASA in do research in London School of Economics, and I think his approach to cities as systems are wonderful. So yeah.
Cool. And last but not least, typically I ask, what's your favorite building in the world and if you have ever visited? But we're gonna change it for you. So what's your favorite city? And have you ever visited?
Yeah, no,
Let's do
that's
that.
impossible. Only choosing one. How
But you have to
can
choose one. Like let's say you live in Argentina, but you have the opportunity in your life to only visit one city again or for the first time, but you only have one opportunity in your life. Which city would you choose? Let's put it like that.
No, it's impossible. I am doing my best, but it's impossible to only choose one. Yeah, let's try to create any criteria. I don't know. I don't know.
On a
Yeah.
personal level, I mean it's on a personal level, like the one that you think would enjoy more um for a weekend, or you can say one or two, or if you want to add more to the mix so it's easier.
Let's say I love many cities in Galicia because of the food and because my grandparents were from Galicia. So let's go in that direction, the direction of the heritage. So yeah, let's say small towns in the Rias in Galicia.
Galicia. Okay, good choice. um and before we say goodbye to each other, can you tell everybody where they can know more about Urbanly or contact you as well?
Yeah, sure. So we have the usual social networks, LinkedIn, our webpage, YouTube, and all that, and yeah, my I mean my message to the audience in this particular time is that if you are urban planning or staff working in a particular city and you think there is any interesting application on this land use simulation technology, not I am not talking about a commercial project, but I am still a researcher, so I love to experiment and if any in the audience like says this particular phenomena is happening in my city, please let me know, because that will be a wonderful opportunity to experiment with the models and try to push the state of the art on the models. So my email is fede@urbanly.org. So feel free to write me and yeah, let's talk and let's discuss this topic. And of course, it's my passion, so always happy to talk about this.
Absolutely, man. Thanks so much for your time. For me, I had a blast. It is so interesting what you are doing, and the mix and the passion you put into it. So I really appreciate the time and being so humble to share all the or a small piece of all your knowledge.
No, thanks to you. Thanks for the invitation and for having me. Thanks a lot.
All right. Thanks so much, and I hope to see you on the next one. All right.
Thanks to our listeners. If you like this content, you can find past and upcoming episodes in ascworks.everse.com and at all of our Everse social media. We'd love to hear from you and recommendations for new content, so leave us a DM and we'll make sure to catch it.